Good morning everybody. This is Shilpa. Welcome to Empower. Today we're going to start with matrices, class 12th. To start with matrices, it is an elegant and a powerful mathematical tool which will help us to solve problems not only in mathematics but also in very different fields. We can come across matrices in your engineering as well as in your physics, economics as well as statistics. And at present, I would say that it is very much useful in a upcoming languages called as machine learning, and I would also say that the Python. You need a knowledge of this matrices which is very much helpful for your upgrading your skills and all. To start with the matrices, I would say that matrix is a word. The plural part of it is said to be matrices. So matrices as a definition, we'll see how the matrices works. What exactly is the definition of a matrices mean? I would say that matrices is an ordered rectangular array of numbers or functions. Okay, the rectangular array, here array is nothing but it's an arrangement, or in your general terms, in your normal way of speaking matrices, I would say that it's an arrangement of numbers in rows and columns. That is said to be the matrices. Always the matrices has been denoted by capital letters, and note that the elements within the matrix should be in small letters. You can never use the capital letters for matrices, even the elements of a matrices. The matrices can be denoted with the capital letter always, and the elements of a matrices should be in small letters. And how do we denote a matrix? So as I already said, a matrix is being started with the capital letter A, which is equal to you will be representing within a square brackets, or we can also, certain books they follow a brackets which is just an open brackets, open and closed brackets, or there are certain books which will represent within the two vertical bars, which is something of this kind. Okay, but usually you can look into your textbooks where we'll go with the normal square brackets. And these are the elements of the matrix what we come across within the matrix here. This is the way of representing a matrix. And the elements in the matrix which can be represented within a certain rows and columns. The next thing that we come across is said to be the rows and columns. Clearly you can see in the matrix A, the first matrix whatever we have. The horizontal lines, whatever we have, these are the horizontal lines that we come across. This is the first line, second and a third line. The horizontal lines, whatever we have, the elements within the matrix are said to be the rows. So I can see here in this particular matrix, I have three different rows, R1, this is R2 and this is R3. We have three rows. When it comes to the columns, the vertical lines are said to be the columns here. So we'll see that in this same matrix again, I have two different columns. This is C1, this is C2. The same way, when you have to look into the second matrix, I have three different rows here because we have three horizontal lines that we come across and three different columns we have. So I have three columns which can be represented as C1, C2 and C3. The same way, I have R1, R2 and R3. Three rows and three columns. So this is about the rows and columns that we come across in the matrix. Next, a very important thing that we come across is called as order of a matrix. So the matrix having m rows and n columns is said to be the order of a matrix. For example, I'll take an example here. We have a matrix A which has been considered as a 3 cross 2 matrix. So clearly I had explained what is this 3 cross 2. Here we have 3 rows and 2 columns. So clearly we can see this is the first row, second row as well as the third row. 2 different columns, C1 and C2 is what we have. So it is the order of a matrix will be represented on the bottom of the matrix on right hand side. That is how the order will be represented. No matter whatever the order here, you can have m number of rows, you can have n number of columns. But always make sure that the rows will be written first and then the columns. Always m is nothing but the number of rows and n is nothing but the number of columns. Again, another example what we have considered, we have 3 different rows, R1, R2 as well as R3 here. The same way, column 1, column 2 and column 3. So the number of rows here is 3 and the number of columns here is 3 again. Coming to the third example here, we have a matrix given. Clearly we can see here we have 2 rows and 3 different columns. So when I'm writing a order of this matrix, it is nothing but it is 2 cross 3. 2 rows and 3 columns. So this is how we represent the order of a matrix. Moving to the next part of it, we have few questions based on working on the order of a matrix. Then we'll move with the next concept, which is the operation of a matrix, how to add and multiply the 2 different matrices. Yeah, the first problem of your exercise. So we are supposed to find out, the matrix has been given here, we are supposed to find the order of a matrix. So again, looking at the matrix itself, clearly we can find out the order of a matrix here. We have 3 rows. This is the first row, a second row and a third row. We have 3 rows and we come across 4 columns here, C1, C2, C3 and C4. So the order of this matrix is nothing but it is 3 cross 4. We have 3 rows and 4 columns. So order of the matrix is nothing but 3 cross 4. The next problem, again looking into this, we have 3 rows and 4 columns. We have a first row which is 2, 5, 19 and minus 7. Second row 35 minus 2, 5 by 2 and 12. And a third row, a certain number of elements. We are supposed to find out the number of elements, not the order here. So order we just went through, which was nothing but it is 3 cross 4, the number of elements. So before we go with the number of elements, we have something called as the address of a matrix. So what is this address of a matrix? We have to find out which element belongs where. So to find out that, a general way of representing will be given. For example, if I consider a matrix, say I have A, B and C here, and I have an element cos x and I have an element sin x and tan x here. So clearly we can see it is a matrix of order 2 cross 3. Now, the address will be given for this matrix. How will you define the address? It is usually represented by A, I and J. I'm writing it once again. It is A, I and J. We have Aij, the I denotes the row and J denotes the column. Coming to the elements what we have here, we have the first element which is A. So this can be represented as A11, that is, it is in the first row, first column. The same way when it comes to B, it is in the first row, second column. Clearly we can see it's in the first row, that is R1, and this is in the second row which is R2. So now I can say that B is in the first row, second column, C is in the first row, third column. Same way when it comes to the second row, cos x, here it is in the second row, first column, second row, second column, second row, third column. So the number of elements can be easily analyzed looking into the order. So we know the order, as I've already said, it is a matrix which is of order 3 cross 4 here. Right. So the number of elements will be 3 into 4, which is equal to 12. So we can say that we have 12 elements in a given matrix. So this was a very simple question where we just have to find out the number of elements in a matrix, which can be analyzed through the order of a matrix. Now we are supposed to find out the elements, which is A13, A21, A33, A24 and A23. So they have given a matrix here. It's the same set of elements what we have. In fact, the same matrix what we have seen in the previous problem. But the question here is different. We are supposed to find out what is A13, A21, A33 and so on. So what is this A13, A21, A33? This is called as address of a matrix. The matrix, the elements what we have within the matrix will have certain address. That is how we recognize which element is being placed where. So what is that address? It is being denoted by a small notation called as Aij. So where I denotes the number of rows, which row the element belong to, and J denote which column the element belong to. I repeat once again, I denote the row the element will belong to, and J denote the column the element will belong to. So coming to the first element in the first row. Here, this is the first element what we have it in the first row, which is 2. as we already know, it is the first element of the first row, so that I can write it as A, 1 and 1. I is also 1, J is also 1 here. When we come across the second element of the first row, which is 5, okay, that can be written as A, 1 and 2. I denote the row and J denote the column. We have the second element of the first row, which is 5, so it can be represented as 1 and 2. Similarly, if I have to find out what is the element which is over here, which is minus 5, okay, it is in the third row, that is clear. We have it in a third row and it is in a third column, so that can be written as A, 3 and 3. So this is a third row, this is R3 what we have, and this is C3 what we come across. So clearly I can say that this is third row, third element, third column, so which can be represented as A33. Now coming to the problem, we are supposed to find out what is A13, A21, A33, A24 and A23. So coming to A13 here, A13, this is the first row, third element, right? First row, third element, first row, third column is what we have, which is nothing but 19. So I can write A13 as 19. The same way, A21, second row, first column it is. So A21, which is the first element of the second row, which is nothing but 35. Similarly, I need to find out what is A33, just now we discussed, which is nothing but minus 5. A33, which is equal to minus 5. Then A24, second row, fourth column. Second row, fourth column is this one. This is the second row what we have. The fourth column is this. So I can say that A24, which is equal to 12. Similarly, A23, second row, third column. So A23, which is equal to 5 by 2. So this is what the address of a matrix denotes. In general, we have a certain way of representing it. When we have m rows and n column, the same thing will be repeated. We'll be representing it as A, M, N or A, N, M, depending on the number of rows and number of columns. Yeah. Coming to the next problem. If a matrix has 24 elements, what are the possible order it can have? So we are supposed to find out the possible orders. It can be a 1 row, 24 columns we can have. It can be a 2 row, 12 columns. So just now we saw one of the problem which we had to work on, finding out a number of elements. So what we did there, we just had to multiply the rows into columns and find out the number of elements. Similarly, I need to find out, they have given the number of elements here. We need to check what is the possible orders that we can get into that. So coming to this one, I can say that I can have a single row into 24 columns. So this is a one possibility which I can give. I'll be getting it as 24 itself, 24 elements. The same way, I can have a 2 rows into 12 columns. So this again will give back me 24 elements. And same way, I can write it as 3 into 8. Okay, so which will give back me 24 elements, or I have another option. I can have 4 rows and I can have 6 columns. So this will give back me 24 elements. Not only these 4, the next 4 can also be possible. Like I just have to reverse it and find out. I can have 6 rows and 4 columns. I can have 8 rows and 3 columns. That option also will be possible. 6 rows and I can have 4 columns, which will again give back me 24 elements, or I can have 8 rows and 3 columns. This is again will give back me 24 elements, or 12 rows and 2 columns, which is again 24 elements. I can have 24 rows and a single column can also be possible. It is 24 into 1, which is equal to 24. So these are all the possible orders which can be used to find out the elements which has 24 elements within a given matrix. The same way, we have another sub-question here. What if it has 13 elements? So it may not have these many options. Since it's 13, it's an odd number, and it can be multiplied with 1 and 13 or 13 and 1. So we have only two options here, which is 13 rows into a single column or one row into a 13 column. So which is again 13, and this again will give back us 13. I hope all of you are getting it. So when you have to find out the possible orders, so this is the pattern that we have to work on. Even the reverse order, when we have an order given, what is the number of elements can also be found out using the same technique. We have another problem which is just similar to the problem what we have worked on. If a matrix has 18 elements, what are the possible orders it can have? Again, it's the same thing, 18 elements, just like this problem what we have solved just now. It can be single row into 18 elements, which will give back me 18. Or it can be 2 rows into 9 elements, which will give back me 18 again. Or I can write 3 into 6, which will again give back me 18 elements. Or the vice versa of it. I can have 6 rows and 3 columns. I can have 9 rows and 2 columns, and I can have 18 rows and a single column. So this is the way of writing a order of an elements whenever we have the number of elements which has been given, finding out the possible orders which can be written in a certain order. Coming to the sub-question of it, what if it has 5 elements? Just same as the previous one again, since again it's an odd number, I could say that it can be 1 into 5, or it can be 5 rows and 1 column. Okay, so single row, 5 column, or 5 rows, a single column will give back me the order of a given matrix. We are supposed to construct a 2 cross 2 matrix. Till now the matrix was being given. We are supposed to find out what are the order of a matrix, or we are supposed to find out which element will belong where, or what is A11, address of a matrix, all such things. Now we are supposed to construct a matrix using a condition given. As I already said, the matrix will be denoted with Aij. This is what I had already discussed. It is nothing but Aij, where I denotes which row it belongs to and J denotes which column it belongs to, whose elements are given by. They have given a condition here. What is Aij? Aij has been given as I plus j the whole square over 2. We are supposed to find out what are all the elements which will satisfy this condition. So first thing is, since they have given it as a 2 cross 2 matrix, you will be having elements as what? You will be having elements as A11, which is the first row, first element. You will be having A12, first row, second element. A21 and A22. So this is a 2 cross 2 matrix. 2 cross 2 in the sense you will be having a 2 rows and 2 columns. This is what the elements what we will be having: A11, A12, A21 and A22. So how do I find out A11, A12? Clearly here we can see that it is A11. That is, I is 1, j is also 1. I will be substituting that I and j in the given condition here. Aij as I plus j the whole square over 2. When I substitute I and j as 1 and 1, whatever the value that I'll be getting, that I'll be that will give me the first element of the first row. So we have Aij here as I plus j the whole square over 2. So I'll be considering I is equal to 1, j is equal to 1 again. So when I come back and substitute here, it is 1 plus 1 the whole square over 2. Which is nothing but 1 plus 1, 2, 2 the whole square will be 4, 4 over 2, which is equal to 2. So now I got what is the first element of the first row, which is A11. Similarly, I need to find out what is A12, A21, A22. So A12 now. A12. So clearly I can say that here I is nothing but 1 and j is nothing but 2. Just substitute what is the value of I and what is the value of j in the given condition. So I'll be getting it as, it is 1 plus 2 the whole square over 2. So 1 plus 2 the whole square, it is 3 the whole square, which is nothing but 9 by 2. Same way A21. So I is 2 and j is 1 here. Same procedure. It is A2 and 1. So I is 2, it is 2 plus 1 the whole square over 2 again, which is 3 the whole square, which is 9 by 2. Coming to the last element, the second row, second element, which is A22. So A22 is nothing but 2 plus 2 the whole square over 2, which is 4 the whole square over 2. So 4 square, which is 16 divided by 2, which is equal to 8. Now I ended up with all the elements which are required here. The final matrix, I can write it as the first element as 2, second element in the first row as 9 by 2, first element of a second row as 9 by 2, and second element of a second row as 8. So how will be the final matrix that I can write it here as? It is 2, this was 9 by 2, and this was 9 by 2 again, and this was 8. So we ended up with the required 2 cross 2 matrix, which is 2, 9 by 2, 9 by 2 and 8. A similar kind of another question what we have. We need to again construct a 2 cross 2 matrix, same question, but a condition has been given with a different one here, Aij as I by j. Just the same question where I need to find out 2 cross 2 matrix. So as I already discussed, it is again, we are supposed to find out what is A11, first row first element, first row second element, second row first element and second row second element. As usual, we are supposed to consider I and j based on the given condition here. If it is a 3 cross 3 matrix, then the same again, A1, A11, A12, A13, A21, A22, A23, A31, A32, A33. So depending on what matrix they have asked, based on that we need to work on. So coming to this, A11. So A11, here I is 1 and j is also 1. So I can write it as 1 over 1, which is nothing but 1 itself. A12, that is the first row and a second element. A12, it is the first, I is 1, j is 2 here. So 1 over 2, which is nothing but half. Then A21, second row first element. Here I is 2 and j is 1. So I can write it as 2 over 1, which is nothing but 2. The same way, A22, second row, second element. So second row, second element, and I is 2, j is also 2, which is 2 over 2, which is equal to 1. So finally, I can write the matrix, the required matrix as 1, the first element, 1 by 2, the second element of the first row, and it is 2, and the second element, second row will be 1 again, which is a 2 cross 2 matrix. Yeah. In today's class, we discussed about the introduction of matrices, what exactly is a matrix, how do we represent a matrix, what are the different ways of representing a matrix, and we also went through what is the order of a matrix and certain problems on order of a matrix. And not only that, we have seen how do we recognize what the number of rows and number of columns. And we also seen certain problems where we have to find out the order of a matrix and where we have to find out the address of a matrix. So in the next class, we'll be studying the algebra of matrix, the operation of a matrix, which includes your addition of a matrix, multiplication of a matrix, and different types of matrix, which is a very important concept. Thank you all.